Hello and welcome back to Trev Talks Tech. This is part 2 of the repair of the Elinchrom D-Lite RX4. If you've watched part 1, then you'll know that the situation here is I had the whole thing apart, and my prime suspects for the fault that I found, the problem being the flash over on that PCB, and you can see it just here. There's actually been a flash over there. Probably worth looking back at part 1 if you've not seen it. Anyway, so I've gone ahead and bitten the bullet and bought a bunch of new capacitors, not the big heavy photo ones. I still don't think they're responsible for what's going on here. I'm going to install these, and I've also bought, this all came from DigiKey, by the way. So I've also bought a whole bunch of MOSFETs. Now these are the same these are almost the same as the other ones. They're in a slightly larger package. And it does mean I've got a little bit of a thing to do here, because the MOSFET's not going to fit in its original place without a little bit of modification. So that's all the fun that is coming up. The first thing I need to do is something about this tracking here. I need to get rid of all of the arcing and stuff that's gone on here. Now, first of all, I'm going to just get that tracked in, and I'm going to zoom in on that board there. So I'll try and keep it. I'm still learning about how to keep things in shot, and also realizing that the unit doesn't always track my movements. So there you go. That's what's going on there. Let's zoom in just a wee bit further. There you go. So I'm going to start by sorting out some of this burnt tracking here, and I have here my Dremel. I've got the little handle attached to it, and I've just got a little grinding bit at the top. I'm very carefully going to grind off the carbonized bits of the PCB, and then we will start trying to do some repairs. So okay, I'll try and eliminate some of the noise from the edit here. Okay, that's got rid of the carbonized bits. Don't propose to use the plumber. Much more good tool when you need them. There you can see I've just tried to point this out here. Just try to get rid of that. You can see there's a big patch there now, and yeah, just taking out any element of carbonization. What I'm going to do now is to flow some solder on out. One side of the track is quite wide, and it's the ground side. The other side is a lot smaller. That's going to need probably a little bit of repair wire on there, and for some solder to go over it. What I then propose to do is to cover this part in silicone, just to make sure that a flashover there is unlikely to reoccur. Of course, that doesn't mean that it can't occur somewhere else between those tracks. There's plenty of adjacency between these two tracks as you go round the board. But I just want to make the best of this part, and then we'll go from there. So let's get the soldering iron on. Okay, so just going to tin some solder here. I've got my old solder, and you know what they say, old solders never die. Let's try it. Let's just tin these areas. Had all that arcing damage. I'm just going to lay a bit of copper wire across the PCB where it was, and I'll just tin the end of that just to get it just to get it to sit in place. Let's move that random bit away. Okay. Sit across the whole track with the burned off. And I can resolder the diodes. I'm happy that the diodes are actually fine. Just get all these connections back on. Why is it the smoke always comes towards me? Do you know, I've had always had this for some reason. Whenever there's been smoke in my vicinity, it always seems to drift in my direction. Did anyone else get that? I'd rather it didn't. Okay. Right, so let's just snip that off there. Need some nice little side cutters. We'll take that bit off of there. And let's just go trim down any other bits. And so I'm not going to bother repairing the other side. I don't think it really needs it. It's going to need a little bit of a brush down in a moment, but I'll do that once we've got the rest of the capacitors back in. So let's have a look. Let's do a little bit of unbagging. And here are my new capacitors. Let's just take these out of their packaging. The GK did not take long to send me these, I'm pleased to show. Here they all are. I bought 5, and I must admit I was really just guessing as to the obviously I knew the spec, but I was really guessing as to the size of the replacements, and it looks like I got it right, because these are also Rubicon. Well, these are Rubicon, and yeah, they are okay, different batch number obviously, but they are definitely the right ones. So let's get these soldered in as well. Now yeah, let's do this first, because I can support this on here now. Awful lot of gunge back here from the soldering. Okay, so thankfully the PCBs all have markings on to indicate which side is which. There we go. Which means I'll just stick those on there at each end. I'll try to put them at each end. Come on, indigo. There we go. That's the start of an old joke there. Anyway. Right, and let's have my new capacitors in place, please. We are actually tracking this. Very pleased with the Osmos tracking abilities, by the way. Very pleased indeed. It's taking this very nicely. Okay, there's this one. Okay, it's doubly sure that I've actually got them the right way around. Plus side to plus side. Yep. Okay, let's get the other two on. Yeah, you see, I had to do this before I got the capacitors on, because they are obviously on the same side of the board. So let's continue. that next one, please, to go there. I wonder if actually I can just put these both in there. If I can just get that one in as well. So turn the board around. No, try again. Indigo. In you go. That's it. Right, so let's get these in place, and then we've got the fun with the MOSFETs, MOSFET to come. So get that in there. Tap around it. Go. Do the other leg of the other cap first. Give that one a chance to cool down a bit. Okay. Nice and smooth. Up to this one. Very chuffed I was able to get the right make, and these are exactly like for like. It's actually ChatGPT that recommended DigiKey to me, and it was a good recommendation, I think. So there we go. We've got our new caps all connected, and all the positives go the same way, as indeed they do on here. Right, that's great. So the next thing is this blessed MOSFET then. Now this MOSFET, let's dig out the other one, and also we'll have a look. I need to make sure that is recognized as a working spare. For all I know, the other caps are fine. I do actually need to get, once my component tester arrives, I will be looking into using that to sort out, which capacitors may or may not have actually gone. And maybe none of them did. Maybe it was just the MOSFET that went bang, and that was the end of that. Now, speaking of MOSFETs, here we go. The original MOSFET is in a TO220 package, and the replacement, and I know these are static sensitive, so I'm trying to be very careful. The replacement MOSFET, as you can see, again, I need to get the camera to focus, that is, good heavens, come on, Trevor, excuse me, is in a much larger package. There you go. But it is the same 10M or 10N120B, but this is BN, and this one, as you can see, is BND. I will admit that I don't know what difference the D makes, but I do think it will be fine nevertheless. So we've got it in a heatsink. The heatsink is certainly holding it against the back there, but what I've got to do is get that fitted into here. I'm going to have to, I think each of the holes is slightly too small, and obviously the pitch is about double what it needs to be. So I've got a little bit of bending. I won't bore you with the details of that. So I'm going to get this bent down to the right size, and I'm going to get it fitted into that bit, and then I'll be back. Oh, so we're getting there. Caps are all in, as you know. I've already put the MOSFET, I've actually bent the MOSFET legs down to the appropriate size. You can just see that there, and they will fit in nicely. I do have to try and expand the size of the PCB holes a bit. Right, so we've got, let's bring this over here, and we've got a few holes. Now this is not the most exact science, but I'm trying to get through, to make these holes slightly wider. I've had to resort to a pair of mole grips. I think that's, not sure what you call them in the States, but the ones that use the tension in the metalwork to actually create a grip, and I'm using that with the smallest drill I can find that's larger than the hole it already is, to expand out the PCB holes. But very, very fine job. Actually, not something I care to do with a Dremel, and it's worked. See, there we go, and that's all the holes fixed out. Now the question is, can I get this to sit in there correctly? It's going in all right. The heatsink is not quite making it. There's a tiny fraction of extra fraction in there that's not going to go in. But I'll tell you what, that's close enough. That's close enough, I think. There is the MOSFET in place. The larger holes do appear to have worked for that. Sorry, it's really hard to find a good angle for this with the light and everything. But you can see it just up here with the leads poking through. Just going to solder that into place now. And I'll have to solder in the heatsink from the top, and I've just got to hope that that is going to work, and it's not going to be too much of a problem not being able to solder it right through. There's no plating, there's no tracks on the other side, so I reckon I'm okay. Okay, right, so I've got to solder the VDR as well. Okay, so let's just get this soldered in. That's not too bad to get to. The other one's a bit awkward. And at the same time, of course, I'm attempting to keep this in shot. So hope you can see what's going on there. Actually, it's very hard to find the right angle to do this. So I'm just going to come right up and over this. Here we go. Whew, okay, there it is, resoldered, and it's looking the part. I have to say, it's looking the part. So everything is back in as it should be. There was a bit of thermal paste on there already. I'm basically using that as I don't have any other. And the only other thing that needs to be reinstalled on there is the thermistor that was going across the front of this. So just going to reinstall that. Looks like the legs are bent out a certain way, but I need for them to try to avoid getting too close to the heatsink. Now, because the thermistor, I should say the MOSFET's a bit deeper as well than its predecessor. The only other problem with that is, of course, that it's a bit closer to this component. It's a bit closer to this thermistor component than it should be. So I just had to bend the legs out a bit to compensate for that. Grief. There we are. Okay, that's the thermistor back in place. Just going to get some solder on there. There we go. Okay. Right, so there are a couple more components to go back on. I've got the relay, which after a little bit of looking at, I don't believe is any problem. And I've also got to reattach a capacitor. Now the trouble with the capacitor that I need to reattach is that I messed up the track, and I definitely need to re-establish a connection there. Yeah, so that might be a tad awkward. So yeah, one more cap and the other relay to connect, and then this board will be back together, at which point I can think about reassembling and then testing this kit again. So that's the capacitor back on. I appreciate it's hard to see, but there is the repair just here. And yeah, quite awkward getting a solder joint at the other side of that, but I seem to have managed. Okay, of course I have nothing more than just blind optimism that this is going to do the job, but there you go. That's what needed, just a tiny little dab of silicone. This happens to be Unibond bathroom and kitchen sealant, but hopefully it's not too acidic and isn't going to do anything, you know, to the board. I don't think it will. So let's just put that away. Decorating box, which some of you may have noticed on other bits of the video. I'm just going to let that cure now, and so the next job will be to just do one final look around the board, check to make sure that everything is back in situ, and then I can start to reassemble this along with the display and the main photo flash discharge board, and indeed the other set elements of the power supply as well. So that's a whole bunch of stuff right there that needs to be put back together, and here is a small presentation of the collated boards. There we go. Okay, so I've inserted the MOSFET and the new capacitors. By the way, my Fenosi component tester turned up. I don't know if this is a great brand or not, but sometimes just by being on the internet everywhere you look, there is a tendency to assume it must be a good thing. But I'm for giving it a go, this little component tester, and I used it to check all the capacitors, which actually said that they were all a bit on the low side, but within spec, with a very low ESR, so their series resistance was actually very low, and that kind of that actually correlates with the tests I did to see that the capacitors were charging up okay and at the right sort of rate. So I still don't know whether they were responsible, but one thing I did discover is that this device, this MOSFET, definitely is not right. So I'll put it on the tester here. So it's one of those testers where you plug in a little ZIF socket there, like so. It doesn't really matter which way it goes round on those three. But it should be telling me something about this device. Is it saying? It's saying unknown or component damaged at the moment. Let's just try that. That's plugged around the other way. And as you can see there, I tend to turn the active track off. As you can see there, it's showing capacitance for a device which is actually a MOSFET. I'm just going to try it the other way around and see whether that actually changes. Testing process, and now you can see it says resistance. So there's some change in characteristics for turning this around, but from my own tests on this MOSFET, it should identify very clearly as a MOSFET, and it doesn't. Just one quick test actually I might just do is that I can plug into here. I'm just going to bring this down. Going to take one of the other MOSFETs here and just hook it up to the component tester, just to satisfy myself that even though my suspicions lie with the MOSFET, that it's not, that it is actually genuinely failed. Maybe this device doesn't actually record them properly. It should do, it certainly should do. It's designed to do this. So let's just have a go with this. Right, so that's all of the leads attached in the, not quite in the correct order, as Elinchrom would have said. Right, so here's the MOSFET hooked up to some wiring. This is a good one. This is supposed to be a good one. Let's have a look at what happens when I turn this on. Test in progress. And it says diode. Well, that's different. That might not be the whole story, but it's certainly in the right ballpark. Let's just turn that around. I've just turned that around. I'm just going to try it again. And it does at least say diode. Now that might not be the right answer as far as the actual component's concerned, but it's very different to calling it a resistor one way and a capacitor the other. So I've got to say that is, while not being entirely truthful, is nonetheless a bit more informative. So I'm now going to put this unit back together. So hopefully I can remember where everything goes. Take the fancy wires out of there and just hope for the best. Not going to fully reassemble it, only insofar as is necessary to prove that the components actually work here. But let's just bring this up a little bit and out a little bit. Okay, so the first thing then is let's reconnect the low or this board in here. That's taking those on, and then we've got a capacitor. Looks like I'm going to have to just attach that first. Let's take the wiggle the board out again. Let's put this on, like so, and once again reattach that. I've got a little come on. So there's two large heavy current sort of connectors there, and actually they are going up to the strobe connections, and there are also there's one sort of 6-way little connector as well. So right, that's the first bit. Then this needs to go on, this belongs on here. As you can see, I'm not putting everything back together in its fully missing out slightly. That needs to go on there first. The mains board, and then the low voltage display board goes on after that. So far so good. Going to reconnect the fan. And there, and then that leads up to here. I will put the reflector back in. What I'm going to do when it comes to it, I'll have the whole thing switched on and I'm going to stand well back. I know that sounds, you're probably thinking, oh my God, what a chicken. But yeah, I've lived this long because I've been, and I've had some experiences with the mains that I don't wish to repeat. So, and with high voltage capacitors, or rather, I don't want to experience any problems with high voltage capacitors. So there it is, put back together, good enough for now. There's a lot of structural bits of plastic that need to go into it really, but fundamentally that is it. The only thing I have to do is reinsert the fuse into the mains input. All the other fuses are inserted and intact, so that's good. And then we can turn it on and see what happens. I'm just wondering, actually, you know what, I'm going to, without screwing it all together, I'm going to put it back in its case, and then I think that'll be the safest place to run it from. Okay, the unit is now plugged in to the mains, and I can't remember whether I actually switched it on, or I think it's in the off position right now on the switch. I'm going to switch that on here. Yes, that's right, I haven't got it switched on at the actual mains yet. But and I'm going to flick the switch and see what happens. Wish me luck. And the light is on, and it's flashing away at 5. That's its highest rating. Oh, E4. Okay, that's because there's no lamp in it. That, however, is an extremely good sign. That means that it didn't explode. Let's insert the lamp and just try that one more time. Okay, the lamp is lit and it's trying to build up to the right size at temperature 5.0. And unfortunately I've still got an E4 error. Now I don't know what's causing that, but that sounds a lot like the error I actually possibly had in the first place. But at least it didn't go bang. So that's a good start. It would appear maybe that the MOSFET is well, if hopefully it is actually working. Now that does of course leave me in a bit of a quandary, because now I don't know exactly what the problem was. I need to go away and find out what E4 means for this device. I'm sure that when that's come up before, that it's been to do with the lamp here, but I don't know. Let's go away and check what E4 means. So I've had a look at ChatGPT, which is my source of all knowledge when it comes to things like fault codes on different things, everything from cars to washing machines to flash units. And it says the E4 means charge fault. In plain English, and I'm quoting here, in plain English, the flash has detected that the capacitor bank is taking too long to recharge after a flash. So the unit has timed out and shut itself down to protect itself. Elichrom's official advice is switch the unit off, wait about 2 minutes and switch it on again. If the E4 error reappears, Elinchrom recommend that the unit be checked by a service centre. But it does recognise that I have a background in this kind of thing, so it's suggesting it could be a partially conducting flash tube, an aging electrolytic capacitor, which I suppose is possible, but I have checked the small ones that were nearest the site of that arc. I guess now it could be elsewhere on the board. Problems in the high voltage charging circuit, rectifier, switching, transistor, transformer. Now, of course, I have just replaced the MOSFET, so I don't think it's that, and I've replaced some of the caps. Some of the other caps could, of course, be at fault, so what I may have to do is dig those out and have a look. Or it thinks there's a fault on the power board, causing the controller to think that charging is stalled. One of those things. But does E4 appear immediately on power up or only after firing the flash? Can you hear the normal high-pitched charging whine? Does the ready light ever come on before the error appears? It suggests the controller is starting the charging process but isn't seeing the capacitor voltage rise as expected, and after a timeout declares a fault. So either the inverter isn't actually working, it could be an inverter fault, I suppose, still, even though I've tried as many of the semiconductors as I can think of. The capacitor may still be charging, but leaking current so heavily it never reaches target level. Given the age of these units, that's certainly possible. Could be a faulty flash tube that suggested the flash tube is cracked. There's certainly no evidence that the tube is in any way damaged, so I don't think it's that. Or a voltage sensing fault. The microcontroller isn't actually getting the right feedback. It says if you hear absolutely no charging sound, I'd be looking first at the inverter power stage. Okay, I really could do with a service manual for this and maybe a circuit diagram. That would help, wouldn't it? Having tried the obvious things, the less obvious things really do need a bit more information. Still, there's a few things I can try before I need to resort to that. Okay, thank you, Holly. That's my ChatGPT's name. Red Dwarf, you get it. And let's see what I can do now. So just trying some semiconductor tests here again. I've gone around and discharged all the large caps. And although I've done this for the meter, I'm just thinking, quick component test. Almost an excuse to use the component tester, really. I'm trying them out in circuit, of course. Let's see, there's a capacitor there. Interesting. Is that because there's a capacitance across that diode? Actually, there is. There is actually a capacitor, and yeah, it's reading the capacitor that's next to it. So that's interesting. That it's reading the capacitor. That's out of interest. Just reverse the connections on the diode and see whether it comes up with something. Yeah, it's seeing the capacitor again. So I can't see a diode that's across a capacitor with this device. That's quite an instructive point in itself. So the all the fuses are in, and yeah, that there is, as the ChatGPT pointed out, there's actually I'm not hearing any of the high-pitched noises you might expect with a recharge. So I'm going to be very brave now, and I'm going to reconnect the strobe, simply because I don't want, if it does discharge, I want it to do so into something that's meant to discharge into. I'm not going to put the shield back on, however. So there it is. I'm putting this way, by the way, so you don't get blinded by it. So let's just put the modelling lamp back in. I've also checked the fuse here. There is a secondary fuse here, and that seems to be all right. And I'm going to reconnect it without, and notice how brave I'm being, without connecting it or putting it inside the box. Now I know that it's not going to just explode on me, at least that easily. And hopefully it won't do it now. So it claims to be charging, and not quite sure what the modelling lamp is doing, but then it's going into this E4 again. I don't know whether it's actually going to discharge or not. If I attempt to operate one of the buttons, there's nothing on anything. It's not responding at all. I'm of course a bit concerned that it may then attempt to but there's literally nothing across the capacitors. Or is there? Hey, wow, that one was charged. The other one was not. Oh god, that begs the question, should I do that with the rest? Yep. Maybe if I'd have just waited a bit, I could have expected that to calm down. Let me just get the other cap there. There we go. Well, that it just goes to show that something is going on here. That the other capacitors, are they charging up or not? Let's just try. Nope. The large capacitor bank on here isn't doing anything. The small caps that I just struck myself with, not literally, just surprised myself with, most definitely are discharging. I hope I haven't messed up the capacitor up doing that. Oh dear. Right, so what's going on then? Some parts of the circuit clearly are charging, some parts are not. This is going to take a lot more examination than I have time for right now. So it might be a while. You might be seeing this sometime after the actual part one, because I think it's going to take me a while to get anything out of this, and I'm also starting to question whether it's even worth the effort, if I'm honest.